All right. So let us start. Okay. I'll start by sharing my screen. Okay. Let me know if you can see my screen. Can you see my screen, guys? Well, I cannot.
Yes, clear, Doctor.
You can see the screen.
Yeah, we can see the screen.
Okay. All right. Okay. So let me introduce you the idea of how things are modeled, especially the mathematical models, how they are modeled, and what do we need to know, and some basics about mathematical modeling when it comes to softwares and packages. Okay. So for that, let me create a whiteboard first. Okay. All right. So I hope you can see this whiteboard, right?
Yes, we can.
Yes, we can.
Okay. Sometimes I just ask these things just to make sure that my volume and everything is on the right level. Okay. All right. So in our course, IC 321, we have been building mathematical models, and we have seen methods of solving the integer programs using branch and bound and very basic, just shallow level cutting plane methods. And then we went to heuristics as well. Now in this session, our focus is on the exact methods, especially the branch and bound. Our goal is to take the mathematical model, okay, take the mathematical model that we have designed on or written on a paper, and then convert it to a model, say mathematical model, but this time in a computer package, some software. Okay, so it's just kind of transforming the mathematical model that you had on a paper to something on the software. And this transformation is just a sequence of what you can do, and it's called as model building. Okay, so we are only converting what was on paper to something in software. Then really, from this, you are actually going to solve it and get the solution. Okay, and you're going to get the solution, and that solution, for example, it could be optimal solution or feasible solution, depending on the situation. It could be infeasible and whatnot. Okay, so you get to the solution of your model, and this process is nothing but it is called as solving. Okay, model building and model solving. Now, these are different steps altogether, and you have lots of flexibility in how you do the model building part and how you solve the model. In any software, you have n number of softwares out there, and you can classify all the softwares to commercial softwares, and then the open source are the free ones. Okay. So for model building, you have commercial softwares, open source. For model solving, you have commercial softwares and open source softwares. When it comes to model building, let us go over some of the well-known commercial softwares for model building. And again, I have some inclination on or some likeness or penchantness for this software, which is GAMS. I was using this software, have been using this software for, I believe, since my MS days, so it's huge number of years. Okay. It's one of the commercial softwares that is very useful for model building. And then you have another one, AMPL, very good. And there are many more. In fact, this industry is quite large. But these are some of the ones that I know. Okay. And when it comes to the open source, you also have some model building softwares. And again, the list goes on, but there are really the classical ones, like you go to the naive programming language like C, C++, Java, or Fortran as well, and things like that. And what we are going to learn is this language, which is Python. Okay, to build the software, we are going to use Python. Okay. So that's a quick overview of what are the different options you have for model building. Okay. Now, when it comes to solving, the softwares itself, they have a name. And in fact, the softwares that are going to solve your mathematical models are called as solvers. And probably those are the ones that are typically expensive compared to the model building softwares. And the solvers could be commercial and could be open source as well. If you look at the commercial solvers, and now when we talk about commercial solvers, we have to know what type of model are we looking for. And remember, in the very first week of our classes, we have seen different types of models like linear, integer, nonlinear, and integer nonlinear, just classification. So solvers typically are built for a type of mathematical model. You will have, and our focus is on MIPs. Really, that is what the focus is so far. So for MIPs, we have quite a good number of commercial solvers out there. And a couple of years back, the state of the art was Cplex. Okay, Cplex. It is owned by IBM. It was owned, and it has a history, a chain of owners. But now currently, it is owned and managed by IBM, one of the big companies in this domain. And then you have another popular one, which is Gurobi. And again, there is a history between Cplex and Gurobi. Actually, Gurobi, the guys, three guys, are the inventors of the Cplex, and they started their own company. And there are many softwares out there, commercial softwares that handle MIP. Of course, these softwares, they also handle, quadratic programs as well. But overall, whenever you pick a solver, the software that is used for model solving, a solver, it will have a domain, a class of problems that it can solve. So you have to be, careful with that. Usually, when we use commercial model building softwares like GAMS or AMPLE, they gives you a flexibility that you can model in general and then pick any of the solvers to solve. If you go to the open source, you have two approaches. One approach is to build the model for the solver. Okay, you are going to build the model for the solver. So this is one approach. You write the code for the solver, and from the beginning, okay, I'm going to write the code for Gurobi. I'm going to write the code for Cplex. I'm going to write the codes for Express. Express is another solver. So from the beginning, you have a particular solver in mind, and you're going to write the entire model for that solver. And let's say once you have decided to go in that direction and you would like to change the solver, you will have to restart the code for the other solver that you want to change for. Okay, so that's one approach. But there are certain libraries out there in different solvers, including in Python, that we'll see in our session today, called, for example, Pyomo. Sorry, that's Python, Pyomo. That gives you kind of similar. It is kind of like mimicking, or you can say copying what GAMS, AMPLES, and these softwares do. So it gives you a general framework of building a mathematical model, and then you can pick or choose the solvers later, depending on your needs. Sometimes you would like to test on a free open source solver. Sometimes you would like to test on a commercial solver, depending on your resources, availability of resources, and time, and whatnot. Okay, so there are such flexible options available in the open source, and really, again, I'm not an expert in all of them, but what I observed is that Python has many libraries like the pulp. You have one of the libraries called pulp. You have many libraries to build the mathematical model, but Poemo, I think, is in general kind of good. If you know this Poemo, maybe it will be useful for a good range of mathematical models that you will find in your curriculum or after your graduation. Now, let us see the open source solvers. Open source solvers corresponding to the commercial solvers, open source solvers are there, but the performance wise, there is a big gap between the commercial solvers and open source solver, period. No doubt on it. Because these commercial solvers, they hire PhDs and researchers who will be constantly working on improvising the way the solvers behave. Whereas the free ones, like the coin or has a CBC, or the one that we are going to use in our class today is GLPK. These commercial open source solvers are community interest. Every now and then people from different domains who are interested in OR, they will be participating and trying to use it and then contribute, and that's how these free solvers are existing and are continuing their existence. The thing is that there is a lot of good brain work already done in these solvers, whereas here no, it's a pure plain implementation of your branch and bound, and most probably a few here and there cutting plane. Okay, but here no, it's a smart implementation, and if you remember in our class we have studied the strategies like node selection, variable selection, and branch selection. And these are not the three. There are many more options out there for branch and bound. And in Cplex and Groovy, by default, they have a smart way, a dynamic way of selecting these strategies on the go, and they change it while they are exploring the tree. And that's what makes it kind of superior compared to the open source solvers. And now, if you want to excel in using open source solvers, you have to have very good experience, and then you can reach to a performance level compared to them. But that requires lots and lots of experience. Okay, so we are not going to go to that level. We are not going to take an open source solvers and try to control its parameter to be matching to the performance here. But in our session, what we are going to see is how we can use a free library in Python called Pyomo, and how we can use a free solver like GLPK and solve simple MIPs. First, I'll start with linear program, a simple linear program. Then we'll try to slowly move towards MIP, and we'll see how we can solve them. Okay. So that's the plan of today's workshop. In the chat, I have shared with you a PDF in which we have three simple models. We are going to start with the very first one, very basic one, and then maybe we'll go with second or third, depending on the time that we have. For sure, we are going to cover third one. This third model is it's TSP model, and we have just now posted the homework on TSP. So I will take the homework problem from the TSP homework, and we try to solve the TSP model in the workshop. Okay, all right. So before we proceed, any question, any comments, anything that you would like to ask? Mhm. Are you guys with me?
Yes, but no questions. Thank you.
Okay, okay, right. So it's better to keep on checking, so we know the progress. All right. So well, let us jump to programming, you know, directly. and we are going to use Jupyter notebooks. That's one of the ways in which you can use Python. And among all those different ways of handling Jupyter notebooks, one of the good style is this Anaconda. Oh, I should have typed Anaconda Python. So it's going to take me to the Anaconda, which is, oh, now see, the Google became also smart. It took me to the Anaconda that I was looking for. Okay. So that's the Anaconda. It's kind of like a repository. It's kind of like a resource manager that handles things related to Python and Jupyter notebooks. So it's a one single short solution. If you want to use the power of your computer, the GPU, the CPU, whatever power you have on your machine, then you can go to Anaconda web page and download from there the free individual edition. If you go to this Anaconda distribution, you can click. It identifies the machine. For example, I'm using Windows, so it identifies it. If you're using Mac or any other OS, most probably it will identify it. Okay. Otherwise, you can select and you can proceed. It also gives you an option to code it in the cloud. That's what we are going to do in today's class. Okay. So if you have installed Jupyter notebooks and if you have downloaded different libraries, that's good. You can continue with Jupyter notebooks. But let us say you want to uh, um, let's say some of you are starting from scratch. Maybe it has been a while since you took ISC 291 or worked with Python. Then you can just continue with me starting from anew, and you don't have to worry about anything related to Anaconda or Jupyter notebooks. I'm going to go with something very basic, something very easy, so that everybody will be on the same level as we proceed. So I believe everyone here or everyone in the session has a Gmail account, right? Is it a valid assumption? Is there anybody with no Gmail account here? So if there are no replies, then most probably everybody has a Gmail, right? So please click open your Gmail account and go to your Google Drive, and you should find something like this Google Drive. No, and there should be a space, and well, I have an empty space. I just I use this account only for modeling, so it's empty, it's clean. But you must have some folders if you are using Google Drive, and you will have here some space used. But all I want you guys is to open your Google Drive and be part of this drive. If you don't know how to go to Google Drive, just open your Gmail, click on this button here, and then it will give you the drive option. Click on the drive, and it will take you here. Okay. So maybe we'll wait for a minute for everybody to be in this page. Okay.
Doctor, can you repeat how to come to your page, because I lost my connection.
Okay, so this is Google Drive. All you have to do is you can go to Google Drive directly. Just log into the Google Drive or go to your Gmail, and in the Gmail, click on this button here, Google Apps, and you can see here Drive. You can see all the other apps as well, but right now what we need is Google Drive. Click on Drive, and it will take you to Google Drive. You can see it's, if you look at the link, it will be drive.google.com. Okay. And this is a workshop. This is not a class. So if you guys need any help, if you want to ask any question, please text on the chat or you can directly ask the question. Okay. So everybody with me on Google Drive.
Yes, doctor.
Yes.
Okay. All right. So first thing first, let us create a folder in the Google Drive where we will have all our codes, and maybe we'll not have time to see how to read the data, but it's very easy. Once you know how to use Python, then everything will be very, very clear. Okay. So first thing, we are going to create a new folder. Just right click anywhere here or click on this plus. It's up to you. Right click here and say a new folder. Yeah, and give any name to that. For example, I'm going to say ISC321 T222 workshop. Okay. So that's the name I'm going to give. Yeah. So now you see in the drive, it creates a folder with that particular name. All right. Everybody with me so far?
Yes.
Yes, doctor.
So now let's get inside the folder by double clicking. Just double click inside the folder. And now please pay attention. Now right click, click on more. And for most, I believe everyone, if you have not used this before, but for most of you, you will not find Google Colab as a part of the apps. Okay, right? Most of you are not seeing Google Colab, right? Yes, no.
I have no collab.
Okay, so let me repeat it. Yeah, so if you have Colab, that means you have used it. Okay, but for some of you who are have not used it, when you right click in the folder, you will not find the Google Colab. Then all you have to do is just go to, uh, oh, let me just click a little bit higher. All you have to do is click on this Connect More Apps. Click on this Connect More Apps, and it will take you to a panel where you can search for any app and then you can add. And basically, you have to search for Colab and add it to your account. Okay, it's for free. Everything is for free, and you'll see. So there are some interesting features that are provided through the Colab. Okay, and it depends on the internet speed. Most probably, the speed that I'm using is a bit slow, so it's taking time. But maybe it will be very fast on your computers. Okay. All right. See, so it took. I don't know why, and today it looks interestingly very slow. Most probably because of the Teams is taking kind of maybe good internet. Anyways, so here you can search for the apps. You can type Collab, or you can just scroll and you see here, see the collaboratory Google Collab. You just click on it, it will install it for you. Okay. So once you do this, once you install this, now when you click here, you should be able to see Google Colab or Collaborator. Okay. And then click on this and it will open the Jupyter notebook for you. That's it. So is there anyone who cannot see Google Colab in the Google Drive? If yes, please let me know. If not, I'm going to assume everybody can see and I'll proceed. So is there anyone who needs any help here?
Doctor, is it required to use Colab or just it's fine to use the regular
Oh,
Jupyter?
you can use Jupyter notebooks, no problem. But for those who have, uh, have put the Jupyter notebook on site for quite some time, uh, maybe if you don't cannot recollect it from your ISC 303, sorry, ISC 291, then yes, for them only. But for the others, if you are using your Jupyter notebooks directly, it's fine. Okay, all right. So I believe everybody has this. So I'm going to click on this Google Colab. And from here onward, it is exactly like your Jupyter notebooks. There is a small difference. The difference is that Jupyter notebook is using your operating system. It could be Windows, it could be Macintosh, or it could be Ubuntu, the Linux version maybe. Uh, but on Google Colab, it is I think a Linux. Okay, so the operating system is a Google server's operating system, not your machine's operating system. So that is the key difference. Okay. But then there are nice things about it. For example, your machine could be faster or slower, but Google will give you a decent amount of computing power, a decent amount of RAM and processing power that you can use. For example, it's going to connect soon, and again, I'm using dark theme. So depending on your browser's theme, you will see a different kind of color. Don't worry about the colors, it's just the theme. And let me remove the filter that I use, so you will see that that's the right one. Okay, so I was using a filter, so I just removed it. Okay, all right, so that's what you get from Google. Okay, so let us quickly create a new name for that. You can say file and also rename, or you can just click here and rename. You follow this file rename, and we can say, for example, let's say model one. Yeah, all right. Well, before jumping to the model, and I'm going to work on that model that I sent in the PDF file in the chat. Please look in the chat. You will find a PDF model, a PDF file that contains 3 models. Okay, you guys see that?
Yes.
Okay, so we are going to work on it. But before working on that, let's do some basic quick review of some of the things in Python. Okay, in every programming language, you have a mechanism to store the numbers, and that's how part of the program is storing the numbers. The other part is to manipulate the numbers or store things and manipulate the things. So when you store things, you can store them in different styles, and you can store them as connected things together, and that connected things together in Python can be stored as a list. For example, let's say m is equal to a list of numbers. Let's say 1 2 4 5 3 2. Okay, so well, in Jupyter notebooks you have things done in the cells. You can have two types of cells. One cell is the cell where you actually code, and the other cell where you can type your text if you want. Okay, so here I'm using the cell which is coding cell. And how do you know it's a coding cell? There is a small button here that shows it. And in the Jupyter notebook, let me also open a Jupyter notebook for you. And in the Jupyter notebook, you will see the cell like this with this kind of label IN. Okay, so that's the cell where you actually can type your code. So let me quickly go back to the collab. So to create a list, all you have to do is in the square brackets. Let me increase the size of this. Okay, so to create a list in the square brackets, we type list of elements, sorry, elements, and then that's a list. Okay, and you can just print, which is, it's going to run. And I'm running on this machine for the first time, so it's connecting, and it will connect to the Google compute engine, and Google will provide me a decent computing power. And you'll see in a minute. Okay, you see that Google gave me for free, if I see, it gave me 12 GB of RAM. Okay, and it gave me online storage of about uh, um, so this looks quite high, but that is what it shows here. Okay, yeah. So it's a kind of good amount of power that it gives me. Okay. So this is the list that contains, contiguous elements, and you can, it's mutable. You can add elements, you can remove the elements, you can access elements. Okay, so that's one of the common ways in which you can store the items into the list. You can add to a list new item. For example, you can say m dot append, and you can say, for example, 100. And now, if you see what's inside the list, you can see that that 100 is added. Okay, if you want to remove the items, you can also remove. For example, you can say m dot uh, remove. Okay, and let's say 5. Okay, and I can say print m, and now you can see that 5 is gone out of that of the list. Okay, so a list is a way of storing things, and remember, programming is about two things: store things and manipulate things. That's it. So here we are seeing how we can store some elements in a particular order. Okay, and repetition is allowed. It's not a unique thing, and this is a basic way of storing the numbers in Python. An interesting thing that Python also offers is to store them with a key. Okay, store the elements with a key, and that style is called as dictionary. So you have a list where you store the elements one after the other, and to access the element, if I want to know what is the address, where can I find one, then the address of one is 0. Yani the index of one is 0. For example, what is the address in the last list? For example, in the last modified version of M, what is the address of 4? Well, the address of 4, where can I find 4? Well, the address of 4 is the index number 2. Okay, so Python usually does this. It is indexed with 0. Okay, so it starts with 0. So 0, 1, 2, 3, 4, 5. So the address, or you cannot address, because when you say address, you go to the C pointer. So not that address, but how to find any 4. So that's the index where I can find 4. So if I say M of 2, then it will be equal to 4. Okay. So that is how you can access the elements from the index. So the index always will start with 0 and increase by 1 in that order. And if you want to, and the indexing, it can also be referenced from the end. For example, from the beginning, it is 0. From the end, you can have -1, -2, so on and so forth. So it can be referenced from the beginning or referenced from the end. So that's how you can store the elements in the list. You can add the elements, you can remove the elements, you can access the elements from the beginning or from the end. So that is the way you can handle lists. And remember, Python uses the square brackets to access the elements, and the append and remove functions, these are the methods or functions, they use the round brackets or parentheses. Yeah. All right. Well, so that's about the list. Now let's add another cell. In your program, you can have many cells, and all of them will be part of the Jupyter Notebook. And the good thing about these cells is you can run each cell individually. So this will also be easy for the first-time coders to divide the code into parts, so that if you make a mistake in one part, then the mistake will be confined to that part and will be easy to do debug in that particular cell. To create a new cell, just click on this button here, and it will add a cell below the previous cell. And if you want to create a text-based cell, then you could have clicked on this button. Okay, so I'm now working on the code cell. So I clicked on the code, and this is the cell. Now here I'm going to show you how to create a dictionary, and we basically will be needing a dictionary and list a lot in every aspect of Python coding. Anything that you would like to code with. Yeah, I'm not a robot, at least so far. Okay, So we will be using list and dictionary a lot. In general, also in Python programming, we will be using a lot. And for mathematical modeling, it will be a thing. Okay. So let's create a dictionary D, and dictionaries are created in this flower braces. Okay, in the flower brackets. A dictionary, unlike the list, does not have 0, 1, 2, 3 as the index. No, you give your own index, or we call it as a key. For example, I'm going to say that dictionary has a key A and it has value 1. Dictionary has a key called it need not be letter. It could be anything that is not mutable. Okay, it's anything that is immutable. So I can have a dictionary, let's say with letter, let's say uh, the Haran, and then you see the colon, it means this is the key, and then after the colon you have value, which is let's say 25, and then you have, let's say, Riyadh, and then let's say the value is 100, and let's say you have dictionary is okay, and I'm doing a mistake, I'll just fix it in a minute, and then let's say for Jeddah you have a value, let's say 200. Okay, so it's a string, so it should be in the quotes. That's thing that I'm missing. So, yeah. So dictionary always has a key and a value pair combination. And here, for maybe kind of like a convention, I just started with the keys that are string, but your key could be a number and a value could be a string, or it could be the key could be a number and the value could be a number. So it could be any combination. Okay, and let me print the dictionary, and this is how it looks. So you have keys and the values. If I want to print only the keys of the dictionary, then I could have done like this. For example, let's say print d dot keys. And you see now it tells you that these are the keys: A, Dahran, Riyadh, Jeddah, 12, 12, 22. So these are the keys. Okay. The thing about keys is they will be unique. So if you, let's say later on, if you would like to update uh, or add something to your dictionary that has the same key, then it will basically update the old value. You will never find two keys that are similar. So keys will be always unique. Now, how to access the elements in a dictionary? To access the element in dictionary is very similar to the way you access the element in a list, except that in the list you give in the square brackets the index. In the dictionary, you give in the square brackets the key. For example, if I say D of the Quran, I should expect to see a result which is 25. Okay, so that's 25. So that's the key difference about the keys. Okay, so here I'm going to use index. Yeah, let me just show here. Print m of 2, and you will get 4. And here I am going to print something of, and then give the value of key, and it will give me the value stored for that key. Okay. So that is how things, and you can update the values here as well as there. For example, if I update the value here, for example, if I say m of 2 is, let's say, 400, and then if I print m in the list, what will I get is the value being updated at that position. Now it becomes 400. Similarly, if I do this, d of the Haran, let's say, is 225, and now if I print the dictionary, you will see that the Haran is still there, but the value has updated. And you see the Haran only comes once. It's not being repeated. So the keys are usually unique. And if I want to add a new key value pair, for example, if I want to add October and let's say 50, okay, what it's going to do is it's just going to add the new key and value. So if it's a new key, it will be added as is. If it's an old key, it will update the existing value. So that is how the dictionaries work. And the keys could be a string, it could be a number, it could be anything that is not changed. For example, in Python, you have immutables, and an interesting immutable is a tuple. A tuple means it can have two values. For example, let's say home, office. So anything in the round brackets looks like list, but it cannot be changed. Once it is created, the only way to change this is to delete it. Okay. Whereas here in the list, you can see easily that I have added some values, I have removed some values, I have updated some values. Whereas in the tuple, when I create something in the round brackets, it's called a tuple, a tuple. I know maybe one of them is right pronunciation. So when you create it like this, that means that's it. It's something that is fixed. Now there's no way to modify it easily. Okay, you have to break it and then only we can modify. So we can have this, and I can give some number here, and let's print it also. Print the dictionary, and you will see that you will get a key which is a tuple. And why a tuple could be a key? Because it is fixed, it's immutable, so it will be almost as good as you cannot modify it. Okay, so these are the two things that we should know. And again, this is for those guys who took Python maybe a while ago, or somebody who needs a quick review of Python. Okay, so we need these two things at least to begin our modeling. Okay, where do we need this? Well, we need this when we go to problem 2 and 3 in the activity that we have. Okay, so let's start with the first one model, which is let me open the file here first. Yeah. So in this model, we don't need so far the data. So sorry, the dictionary and the list. So we'll try to model it as is from here. So to model this, let's see what we need. Well, we need three variables, x1, x2, x3, and then these variables are non-negative, and then we have the model here. We have objective function, constraints, and restriction on domain. So let's create a new cell. Okay, and in this new cell,
Doctor,
yes,
uh, you can add the photo to the job cell if you need, just to the to this.
for the model,
Yeah, I can just copy the shift
picture.
shift S, then put it here, and it will work for a markup cell.
Yes, but let's first add the libraries, and then we will add the picture. So what we need to build the model is we need to get the libraries. When the, Google Colab has a usual regular Python libraries, but what we need for our model is we need Pyomo. That's the key library, and we also need a solver. What solver do we need? Well, if you have a licensed solver like Gurobi and these things, maybe you can connect it. But we are going to go with the free solver. So we are going to use what we call GLPK. Okay. So we can install Poyomo. It's not part of the Colab default library, so we need to install it. So to install it, this is the version. You can just use the cell and say pip install and Pyomo. Okay, and this will install now the Pyomo for you. So successfully installed Pyomo. It is not installing on your computer once again. It is installing on the Google Cloud, the space that was given to you through Google. Okay, so that's where it did the installation. This is one installation that we need. And then we also need to install or to get actually to download and get a GLPK. Okay, and to get GLPK, you have this GLPK stored again because it's the uh, cloud. It's available here, and you can get it from apt get install, and then that's the code here. And this is most probably, I think, Linux way of downloading and installing things. Okay, so GLPK is here. Okay, GLPK dash utilities. So this will download and install GLPK on your Google Cloud space. Now, if you want to do it on your machine, How will you do this? Well, in the Jupyter, you are going to type the same thing, uh, pip install Pyomo. In some machine it works. In some machine, depending on your Windows operating system and depending on your administrator account, it may not work. So if that is the case, then you have to go to the Anaconda uh, uh, Anaconda uh, prompt, which is, when you go to your uh, um, system, you will find the Anaconda prompt. And in the Anaconda prompt, you can use Conda install. That's another way of installing. Okay, and it might get slightly, annoying because this default for Poemo sometimes may not work. That's why I used here this collab, because the installation part is just very easy. It's taken care by something outside. Okay, and it looks like the that GLPK has been downloaded and installed, and you can see here the moment this thing come back to this icon with the time, it means it has done its completion. Okay, all right. Now let us build this model, and like our friend suggested, let us copy this from here. Let us go to uh, here. That is creating the image, but see if it recognizes it. It's not recognizing. What's done? What's gone? Yeah, I think it needs some time.
Dexter, you can use Shift Windows S. Just cut and then paste it and markup.
Format maybe. Maybe because of the Google collab, maybe it's not working.
Doctor,
Yes, go ahead.
I think you can use Shift Windows S and then it may work instead of downloading the picture.
Yeah, I did that, and it what I took, but I think
Yeah,
Google collab, maybe it's not working. Collab
okay.
might have, could be because of Google collab.
Doctor, also the GLPK, it's not working on the Jupyter. I used the pip install method, it's not working.
No, so maybe that's a good point. So I forgot to mention this. That's a good. If you want to install a GLPK, that's not how you install your Jupyter notebook. Okay, in your Jupyter notebook, what you need to do the GLPK. Okay, and then here you click on this link.
Doctor, your voice is weak, we cannot hear you properly.
Can you hear me now?
Yeah, yes.
Okay. So
Yes, doctor.
go to this link again from the Google. Just type GLPK download. You will go to this GLPK page, and from here download. You will have different repositories, and you download the GLPK. It will come in a zip file, and once you get to the zip file in your folder, for example, wherever you are working in the folder, like we created something here for the collab, you can create something in the notebook. In the folder, just extract the glpk folder. So this is the folder that you get with glpk, and this is how you actually connect glpk in your windows machine. And it could be a different style in macintosh, and I'm not any a user of Macintosh, so I cannot, help for those guys. That's why I prefer to use something like this, so that everybody will be on the same page. Okay, but on Windows machine, if you want to use GLPK, just go to the GLPK web page, and from there you download. It gives you some links, and there are maybe you can also find. Let me show you this one. uh, SourceForge. You can also get from there GLPK. Okay, so you have to download the folder from here, and once you download that, extract it, and you will get the folder and copy it in your project folder, and then you will connect that folder to GLPK. Okay, so it will be in this style. On the collab, yeah, it's easy because it's in a single shot. It does everything for you.
Dr. Mujahid, if I may.
Yes, yes, doc.
Yeah, if you're yeah, for those who are using a Mac, if you are using Homebrew, which is the package manager that you can install for on Macs, it doesn't come with a Mac computer by default. But if you're using that package manager, if you know what I'm talking about, you can just simply do brew install glpk in your terminal, and that should install glpk very easily. If you're not using Homebrew, then I'm afraid you're on your own because I haven't. I mean, it's on the website that Dr. Mujahid shared. I'm sure the instructions for Mac. Homebrew is one of the ways you can install GLPK, but it's not the only way. I think it's the easiest. If you're not using Homebrew, I would recommend it for package management on a Mac.
Let's continue. So let's assume that the guys who are working with lab, they have this step done. The guys who are working on the notebook in Windows, you have done this. And for Macintosh guys, if there are any, then if you cannot get GLPK working, then you can, meet, and maybe Dr. Bauvet, Dr. Ahmed Bauvet can help you, or maybe we can find some resources and we can upload it on the Blackboard. Okay. All right. So yeah, now we have done this. So now let's okay. We are trying to get the picture right. So that was the next task. So well. Let me image. I have clicked on the document, state modified, model one. Oh, so it's the same thing. So in Collab, this looks like the same procedure. I think it should be okay. Yeah, I think maybe. So yeah, here is a picture that we wanted to bring in, and let's add the code below this. So we are trying to basically build this model. Okay, so first thing I would like to now call the Pyomo library, as well as I would like to get in any other library that I need. And typically, you can bring in all the libraries in one single cell so that it will be easy for you to keep track of what libraries you need. Okay, it's just a style, but if you want to have a different style, that's up to you. So I'm gonna import uh, Pyomo.environment. Okay, Pyomo.environment, and usually it's a good habit to give it a name so that you use it a local name so that you use it in your computer, and also almost always I do this, which is to get in the NumPy library, because many times we do many things, and it's kind of good practice that you will get it. Of course, it is computationally not efficient because you're bulking, you're getting a big library, so it will be slightly bulky, but that's okay for us. Yeah. All right, so here we have the installed libraries. Now let's build the model. So model is like a structure. It's like an object that has many things to it. And to create that, we say model, any name, any here, you need not be model. It could be any name for that matter. But it's common practice that we use the word model as model. Okay, but it could be anything. So PYE is your Poemo environment dot. Now Poemo environment has many methods, classes as well, methods and classes. And the one that we are going to use is the concrete model. So concrete model, okay. And you can give a name to this model. For example, let's say model 1. So that's my model with just the name, okay. And a mathematical model contains what? It contains variables, constraints, and objective. Typically, these three variables, constraints, and objective. So let's add the variables to this model. So model, again, it's a structure, it's an object, it has many elements to it. So I'm going to say model.x1. And this model.x1 is something that I am introducing. This x1 is something that I am calling, something that is my labeling. It could be anything that I would like, a1, x1, y1, or any name for that matter. But what is this? This is the Poemo variable. Okay, Poemo variable, and every variable should have the domain from where it comes from. This is the main argument. Okay. Of course, in Google Colab, another good thing is it gives you this help right when you type, which will make for the initial programmers things easy. Uh, and that's some thing that you can use. You can also get the same thing, by the way, in the Jupyter notebooks, but maybe here it is more dynamic. Okay, so our variable x1, let's go to the picture again. The variable x1 is a non-negative. Okay, the variable x1 is non-negative. So you have in Poemo environment already non-negative elements. Okay, so you can say non-negative, right? So let me type again. So for some reason, okay, it gave me now. So non-negative reals. That's it. So this is variable x1. And similarly, I can create all the three variables, x2 as well as x3. So there you go. You have three variables that are non-negative reals or non-negative variables. And now we have to define the objective and the constraints. So you can pick any style and work on it. There are different styles out there. What I will do is I will teach you something which is very basic, and may not be efficient, but something very basic to begin with, and then later on we can improvise over that. So I'm going to create an object, sorry, model called OB object, and I'm going to say this is an objective type. Okay, so we have here objective, and you have objective list. Objective is the right choice, but to make things very easy, I'm just going to create an objective list. So I'm creating OB that will store later on an objective. Similarly, I'm going to call this, let's say, as constraint number one, constraint number two, constraint number three, constraint number four. So I need four labels for four constraints. So I'm going to do the same thing again. Model dot constraint one. Again, I can say C1, or whatever is easy for you. Okay, so I'm going to say now this is a constraint list. And we have four out there. So I'm going to say here 2, 3, 4. So all I did so far is created three variables that are non-negative and just the labels that will eventually hold the objective function, the constraint 1, 2, 3, and 4. Okay. At this point, if I want to see I'm moving the right direction or not, I can say model dot p print. You see, this is a different type of print called p print. This is a method in Pyomo. I think there are many libraries that use pprint, but here is the one from Pyomo. And when you execute this, it says, okay, we have five declarations. You have these five, which is objective, and the four constraints, and you have three variables, x1. And let's see something from here and see how we can read this. It says variable x1 is size 1, and it's just one single variable. It has no index to it. That's correct. We wanted a single variable x1. It says that the lower bound on the variable x1 is 0. It means the lowest value it can take is 0. And the upper bound is none. It means it can go up to infinity. And the current value is none. It means nothing is decided. So it's just the starting. So there has no current value. Is the variable fixed? No, false. It's not fixed. You can fix the variables. Sometimes you might know that, okay, this should be the value of the variable. So you can fix it and then you get it. For the stale part, we'll just skip it for now. Maybe in the advanced levels you'll see. In the domain part, you see that it's a non-negative real. So we have everything that we need for a variable. Similarly, for x2 and x3, the information is repeated. All right. Now, if you see, the others are still empty. The objective and the constraints, they are still empty. So there's nothing here to look at. Okay. So this is so far what we have in the model. All right. Let us comment the model preprint. Okay. Now let us add the objective and let us add the constraint. So let's start with the objective model objective dot add. Okay. And what do we have? We have 10x1 plus 30x2 plus 90x3. Okay. So we'll say here 10x1. Okay. Plus 30x2 plus 90x3 plus 30x2 plus 90. Well, I did a typo there. Let me just write the numbers and then we'll fix everything. Okay, so here should be, okay, and everything is expression of the object. Okay, so here you see expression is what? 10x1, 30x2, 90x3, right? 10x1, 30x2, 90x3. And here itself, we can skip it, but it's always a good habit so that we know what we are doing. We are going to say sense. Sense means are you trying to minimize or maximize? I'm going to say PYE, Poemo. Well, what are we doing? We are minimizing, right? So I'm going to say minimize. Okay. By default, it is minimize, and you can skip it. But please remember, don't use the default option, at least for this maximize or minimize. Sometimes it could be, it could lead to issues in your code. Okay. So it's always better to have it out there. Okay, so that's it, that I have created my objective. And now if I want to run it again, and you see here, that my objective here, now if you see the objective declaration, before it was empty, now you can see that this is my expression, which is what? 10x1, 30x2, 90x3. Exactly what we need: 10x1, 30x2, 90x3. Okay, and it says that the sense is to minimize. Yes, this is the sense is to minimize. And Poyomo has a thing called active or not. This active or not is not like whether the constraint is tight or it's not of that active. This is a different terminology. What it means is, are we using this objective or not? Sometimes you can deactivate, yani, sometimes you are doing exploration, so you might have so many objectives, so you might off or deactivate one objective and activate another one. So you could have that flexibility. Okay, same thing goes with the constraints. We will see as we add the constraints, it will give me an option to activate or deactivate. This is very helpful for debugging, especially when your model gets complicated. Debugging could be challenging, and this is the easy way to debug your model. All right, so I have added the objective. Now let's add the constraint model.c1.add. And what do we have? We have 38x1, 1x2, 2x3 greater than or equal to 80. So just to uh, speed up the obvious things, we're going to say 38, 1, 2, 80. Okay, 38, 1, 2, and greater than or equal to 80. That's it. You have added one constraint. And then I'm going to add another constraint, which is 9x2, 50x3, 220. Okay, so let's say 9x2, and it is greater than or equal to 220. Well, one thing, imagine if you had a oh, we have equality, so khalas, don't worry. Okay, so that is C2, and then let us add one more, C3, which is what, 2x2, 8x3 less than or equal to 500. Okay, so this part I'm just rushing because there's really nothing except you enter the obvious things. 500, sorry, the 28, 500, and now x1 plus x2, x3, 100. Okay, so this is C4, and it is x1, x2, x3 equals. So for equal, just remember that that's the comparison equal, not the assignment, right? So that's it, equals to how much? 100. All right, so these are the four constraints, and I have just entered them here quickly. And you can also enter it. There's nothing any unique or special in this, the way you enter. Just a constraint, you enter it here. And the same story, let us execute it once more time and read the constraint to make sure that it works. This is the last one, C4. You can see the label here, C4, x1 plus x2 plus x3. Because this is equality type, you see the lower bound and upper bound is both 100. For those that are greater than or equal to, for those constraints that are greater than or equal to, it will be a lower bound. For less than or equal to, it will be upper bound. Let us quickly verify this. Okay, you have 2x2 plus 8x3, the constraint number 3, 2x2 plus 8x3 less than or equal to 500. So this is an upper bound. And you have another one, which is 9x2 plus 50x3, which is greater than or equal to 220. It's a lower bound. So we have everything in the right place, and this is a quick way to make sure that we have entered what we intend to enter, and there is no typos or anything in the way you enter the things. Okay, so it's just a quick way of debugging. All right, so the model is here. Now we need to solve. So to solve, we need to create a solve object. Okay, solver object or solve object, whatever you like to call. I'm going to call it as a solver object. And the solver object is in Pyomo environment called solver factory. Okay, that's, there you go, solver factory. And there I'm going to select GLPK. It's the same keyword, GLPK. And I'm going to say where it is available. So there is a keyword called executable. And I'm going to say here in your machine, if you are using Windows or Mac, you have to browse to the GLPK executable. At least in Windows, it's called as executable. I'm not sure what it's in Mac, Macintosh, but it should be something similar. Okay, so you should be able to go to that link. In the collab, it's always in your user place. Okay, so user, and then you have binary, and then you have GLP solution. So this is where you have the GLPK installed on the Google Colab. On your computer, it's installed, it's in the place where you have stored the folder. For example, if this is the folder, this is in Windows, huh? Again, Mac, I don't know much, so I cannot help you or assist you. Maybe Dr. Ahmed Bawed can, sorry, Dr. Bawed can help you. Okay, so in here, if you see, you go to Windows 64, and here you have GLP SOL. So that's the link you have to. That's the link you might give it here in your uh, um, Windows machines. Okay, so that's how now.
Can you repeat, Doctor? Can you repeat which one to pick?
Yeah. So you have this folder in your system, GLPK, right? The one that you downloaded from the GLPK for Windows or any other source. Inside this, you have Windows 64, assuming you have 64-bit machine, and I believe everybody have this now. If you click on Windows 64, that's it. You will have GLP Sol. It's an application. You can see it's a type application, GLP Sol, and that is the file path to that file that you will add in the executable here. Okay. So this is the way I connected the solver. And now you can see, imagine if I had Gurobi and in our CCS, it was CCSC before, but now it's CCM, the college. And on the college network, Gurobi is available. So when you write here Gurobi, without even giving the location of executable, it will catch it from the server, from the CCM network for you. So you have the full version, the academic full version of Gurobi for you for free. You can execute on, but you have to be on the KFUPM and the CCM network to get that Gurobi. And the good thing about Gurobi is that with your @kfupm.edu account, you can request them for your own personal academic full version of Gurobi. Okay, Cplex also does that, but um, now I am now using Gurobi, so I'm just talking about Gurobi. But you have many softwares out there that gives you @edu for accounts with the free version of the full software. Okay, that's it. So I have created a solver object that has the information that it will be a GLPK solver. So now once I have the solver, let me just comment this print modular print. I can now solve exactly, and I'm going to say solver dot solve, and then what should I solve? Well, solve the model. Okay, and I can store the results in a object called result res, let us say, and from here I can print many things. Okay? So let me just execute it, and that's it. So here you see that it didn't give me any output. If I want to see some output from here, I could have said t equals to true. So it will give me some output of the solver, of the GLPK solver. For example, it says, okay, GLP LPM MIP solver. This is a version, the parameter specified, reading problem data. There is no data. Anyways, there is data, but not from data files. And then he's doing this, writing, and then he's solving it, all the things that the solver did. And finally, it says optimal LP solution found. This is probably the thing that you would like to look at. It took so much time, so much memory. It's a small model, and nothing much. So this is what it gives you. So it gives you a good history of exactly what happened since the time you started to solve till the end and why it solved. Okay, so it gives you the details of the things that happen in your model. And now if you want to get to the solution, let me turn off the t, so let me make it false. I can just delete it, the default version is false, but let's keep there. So if you want to get into it later for seeing the progress, you can see. Okay, now if I want to print the results, all you have to do is you just say the variable name dot pprint. Oops. And this will print the value of x1. And let's print like this. I guess you don't need print, that is too redundant. Okay, so it says that's the value of the variable, and there are many things. And maybe let's say we don't want to have all of those things, then you can say model.x1.value. Okay, and now I can print. Okay, again, this is just making your code prettier. If you want to make it neat and clean, then you can just say this model x1 is and then I can repeat this. So the double cursor doesn't work here. No problem. And there you go. These are the optimal values of your variable. And yeah, uh, that's it. So that's how you solve the model, and you basically you get the result. So that was your first model. Of course, we went over many things, but that's the first model that we have seen, which is a very simple model. We have simple variables and simple constraints. Any doubts, any questions? Uh, any comments?
Doctor, how to get the model without the history? You said that there is two ways, I think. Do you hear me, Doctor?
Yeah, I can hear you. How to get what?
How to get the solution without getting the all steps? You said there's two ways to make solver.solve, but I didn't get you.
Yeah, when you say T false, it doesn't show you the steps, but if you make it true, then it shows you all the outputs of the solver, basically, not the steps any, but the output that is generated by the solver GLPK. And when you make this false, then it will hide the output from the solver.
Okay, so what if I don't want to see any steps? Just like as you did x1, x2, x3, and the objective function.
Yeah, so you just keep this option as false. That's it.
But when I tried on Jupyter, it showed me also along 13, maybe 13 lines. It's printed 13 lines, not the final answer.
But are you sure that apart from these three prints, you will have no other print statement or p print? Maybe you have used model.pprint.
Maybe. Yeah. Okay, sorry, my bad. Yeah, it works now. Thanks.
Well, any other question, comments? All right. If not, now let us move to next model. And for the next model, uh, what I will do is I will jump to model 3 because this is the model that is your TSP model, which is also part of your homework. And actually, I will just go with the homework data and show you how to execute this model. And you can see clearly this model is a generic model, and most probably knowing this model will be any good enough for you to build any OR model. And if you have time, we'll come back to this. Otherwise, you can take this as practice. You try it on your own. And if you face any difficulties, you are most welcome. You can always text me on MS Teams, and we will assist you. Okay. So let's try to model this part. And the distance here is the distance in the homework file. I will just open the homework file in a minute. So now I'm going to create a new notebook. So first let me, by the way, these are always saved dynamically, but if you want, you can also uh, put Control S and save it. And then let's close this. So now you see here in my drive, if I go back, there's a folder, and inside the folder, the model one is already there for you. Now I'm going to create a new one. So just right click, more, and then Google Colab. Okay, it creates a new collab for you. And click on File and rename. Uh, I don't want to change the extension, so I'm going to say Model 3. Okay, because I have installed in the other file um, Pyomo, I don't have to do it again. Because the session is still running. That's the thing. And because the session is still on, I don't have to do that, but let's check it quickly. Okay, yeah. So I think you have to install every time, although the session is the same. So that's okay. Let me just bring it here and let's copy the part from there. So probably this is the a drawback that you have to install it every time, uh, although it's the same session. So let's paste these two part of the codes. First one, most probably let me add the other one in the same single shot. Okay, and maybe I'll just for those of you who I think you all know Python, but if not, this hash is a sign for comments. Okay, so here I'm going to say this was keyword for me, and it's going to install everything for you as, and then okay, it's done. I think I'll just clear the output, so it's sort of behind. Okay, and now we have the libraries that I want, Pyomo environment and NumPy. Okay, and probably we didn't see the usage of NumPy, or even for that matter, we didn't see the usage of the lists and dictionary before, because the model was so simple. You are entering the data directly, but now the model is not. It is simple, no doubt, but it has the indices. The indices. Okay, um, let me just. Sorry, let me just get the picture from here. Okay, it has the indices. So you will see that we might need now things that we have just discussed. Okay, so this will work. Apparently, maybe my internet is slow or something, so it's taking time, but this will work like it did before. Right, so that's the model here. So yeah, let's say model. Okay, so it's a Pyomo environment concrete model. Okay. And we can call some name to that. Let's say model free. All right, so let's go back to the discussion that every model should, a model is basically made up of what? Variables, constraints, and objective function, right? So here, what are the variables in the model? You know this from the class, but once again, what are the variables that you have in this TSP model? Hmm. Anybody like to answer that? What are the
The
variables?
the x's, right?
Yeah, the xij's also
Mm,
what?
the distances,
The distances and
Do you
our parameter distance, our
you
parameter.
use. Okay, xij and use are the variables, and then there are parameters. What are the parameters? Dij n here. Okay, these are the parameters. Now, if you go to the first model, what were the parameters? Well,
10,
these
30,
numbers, right?
90.
Yeah, the numbers.
X1
So we
until
yeah,
X3?
yeah, the numbers, yani 10, 30, 38, all those numbers were parameters. Because were entering the numbers directly, we didn't give any names and we skipped that part. But here, we are giving a name to the parameter because we would like to use a summation and enumeration. So it should be, easy to add through the names. But now we also should assign the values to them. So here is the place where we're going to see how we can add the parameters, named parameters, and how we'll assign the values. To assign the values, ideally you will be reading from an Excel file or CSV file. But here for the short example, for your homework 4, what is it? Uh, Let me open homework 4 from uh, my system. We have small data, so I'll show you how to enter it manually. Uh, so that's the distance matrix. We are going to use this one. All right. Oh, I think, can you see my screen?
Yes.
You can see the screen, right? Okay. All right. So let's add the variables. We have two set of variables, x, I, j, and ui. So I can say, for example, model dot x. The name is x. The indices are I and j. But there is a problem here. The problem is that what are these indices? What are these indices? Well, we have not defined it, and the rule of programming is that if you have not defined it, you will not be able to use it. So now I'm going to define the indices, and this is the first time we are doing this. Let me just increase the size. So model dot indices, and let's give some name to it. I can use I as I, or let's make it capital I, so that I remember that it's the set of indices. Okay, and this is actually called a set in Pyomo. So pye dot set. And like variables, you have a domain. For set, you basically do initialize. Okay, and you can say here what are the possible values of I. Well, if you see from the model, again, it should be clear from the context, from description. But if you look at the model, usually this I is taking the values from 1 to n. Okay, and in the homework, if you see here, what is the value of n? Well, it is 6. Okay, so let's create a variable n. Okay, and assign the value 6. And I would like to initialize it like this. For example, 1, 2, 3, 4, 5, 6. And I can do this for 6, but what if it is 60 or 600? Most probably that will not work, right? So here I need to create my own list or array and dynamically and initialize it. Um, Again, I can go to the NumPy style, and I can say range, and I'll say 1 to 7, because you see it's not included. 6 is part of it, so 1 to 7. And then just to make sure we are working in the right direction, I can just do model.pprint and check what we have in here. So it says it takes the values from 1 all the way till 6. Okay. So this is how I initialize. Okay, and if I want to be really dynamic, so that I can change this n and the model updates itself, all you do is you say n plus 1. So that later on, if let's say you have a different size problem tomorrow, it's a 60, then if you just execute it, you will create all the 60 elements in the set. Okay, so that will be a way to go for bigger, larger scale models. So I have created a set called I, and really, if in the entire model, you only need one set I. I know I and J are one and the same. It corresponds to the cities. Now, given that I have the index I, now I can define variable X. Okay, it could be capital or small. And the same story, pye dot variable. And the first argument, the first positional argument typically is the size of variable x. And if you see here, what are the dimensions of variable x? Two dimensions, right? It is for I and j. And where I and j, they are all going from 1 to n. There's a typo here, maybe we should a comma j. So basically it's defined for the index I and index I. So I'm going to say here, so this model I, writing it twice means what? X has two dimensions. One dimension will span all the elements of model I. The second dimension will span all the elements of model I. So, and once again, I and J is one and the same. It's different style. It's no alias, you can say, but I and J refers to the same set, which is what 1 to n. So that is how we defined variable x with two indices. And now for the variable, the most important thing is its domain, from where the variable is coming, right? And we know that xij, if you see in the model, it is a what type of variable? It's a binary variable.
Binary.
Yeah. So it's pye dot binary. So there you go. I've defined all the variables xij's here. And similarly, ui is another variable. You say model.u, and I'm going to define this variable. And u has only one index, and it corresponds to all the values of I. So I'm going to say here model.I. That's it. So it's only one index. And then the domain of it, what do you think is the domain of this? It is?
should be non-negative.
Yes, it should be non-negative. Yes.
Doctor,
Yes.
so what if I and J does not have the same domain or the same sorry, the same range, or they are not the same?
Then you create another one model.
Okay.
Create another different. Here, because
Okay.
both I and J are the same, I'm kind of, let's say, like, not creating a new one. I'm just going with the. But if they are really
Fine.
different sets, just create another one. Okay, Saleh.
Yes. Thank you. Doctor, your voice is being weak, so can you just?
Yeah, this not sure in MS Teams this is always the case. It kind of dynamically it updates the volume and it lowers the volume. I don't know why. Um, okay, so whenever it goes down, let me know. I'll just get closer to the mic and try to get it louder. Okay. And
Okay.
once again, once you have the variables, anything you have, you can always print and see did we do it correctly or not. Okay, so here you can see that x has now indices 1, 1, 1, 2, 1, 3, and it goes on. And I has one, sorry, not ui. Here it is. Okay, ui. It goes like this. You have u1, u2, u3, u4, u5, u6, and x. You have total 36. I multiplied by j, 6 times 6. Okay. So you have everything here, okay, model.x and model.u. Now we build the objective. So you have one objective. Okay, one. How many constraints do I have here in here? I have how many constraints?
N constraint.
N constraint, but it's one block. And this is where I'm going to create the blocks, right? In the previous example also I created blocks, but apparently that blocks were very simple. But here I'm going to create a block. So this is block 1, block 2. So block 1, block 2, and block 3. Only 3, very short. Okay. So let's do that. Model dot objective is pye dot objective list. Okay. Objective list. And then we say model dot c1 pye dot constraint list, and then I'm just going to repeat it. Okay. So there you go. You have all the three available, and then I'm going to say model objective dot add. Okay. And here is the new set of things that we learn. So how is your objective? Well, it's double summation over dij xij. So to do that, I need to know what is dij, right? How to get dij. So dij is given here to me in this problem here, dij, right? So I need to enter this, or I need to read it from Excel. Assuming that we are getting this directly without entering it, without getting it from Excel, I have to create something to enter the data. So now is the time where I'll be creating some holder for the data, and I'm going to use a dictionary. Okay. So let's create a dictionary, the empty dictionary first. Okay, this is how you create an empty dictionary. Um, and then you can say D, for example. Let me put them side by side. I think this can be done. Yeah,
You can also copy this, Doctor, and put it in
yeah,
Jupyter.
but the size is so big and it's not that helpful. So let me put it on the side screen so at least I can do and from my system. So I can see that D12 is 21. Okay, and again, this is not the best way because I am kind of doing it so manually. Okay, and the best way is to read it from um Excel or some other CSV or some other way of data, file. Okay, 15 is 37 and 16 is 28. Similarly, I can say 2, 3, okay, is 27, and then let me just copy this. 2, 4 is 35. 2, 5 is also 35, and then 3, 4 is 31. 3, 5 is 33, and 3, 6 is how much? 23. And 4, 5 is 19, and 4, 6. Again, this way of entering is not at all recommended. You have to read it from Excel file or any data file for that uh, task, but I'm just doing it manually. Okay, so this is half of the matrix. The other half, again, I can type it, or I could just say like this for I in well, oh, let's do one thing. Let me just copy this below below the model. Basically, I wanted to show you that I could have used model.I as my index. Okay, so assuming that I'm running this after the cell at the bottom, you can see that I can access the values of I. See here, these are the values of I. So I can use this model.I as my iterator. I can iterate over model.I. So I'll do this more for J in model.I. If I is strictly greater than J, I'm just copying the matrix. Okay, I'm just copying the matrix. Uh, if I is strictly greater than J, then D ij is same as D Ji. Okay, and then let's print the dictionary. So it says I don't have 26. Yeah, that's correct. So I forgot to add a 26. Okay, so that's the entire dictionary. You see all the values are available here. Okay, so that's very rough way of doing it. But anyways, we are done with it. So we have the dictionary here. Now let us see how to add the objective function. Okay, summation, that is double summation, Dij Xij. So Dij is just now what we created, which is in here Dij, and multiplied by your model dot Xij. Okay. Now, from where the I and J are coming? Well, I and J's are coming from this set I. So you can say that for I in model dot I, for J in model dot I. Also, as a precaution, because I don't want to use I, and in the dictionary itself, I have no term which is 1, 1. You can see here that it's this 1, 1 or the diagonal is empty. So either I can give a very high number, that is quite possible, or I can just skip it. And to skip it, I can say for if I is not equals to J. So that will be my expression. Okay, the expression is what? Dij xij, and this not only dij xij, the summation of dij xij, and sum is done like this. Sum method, okay, sum dij xij, where I is coming from model dot I, j is coming from model dot j, and I would like to make sure that I is not equal to j. So that is your expression, and then since we would like to minimize, so we can say py dot, that's it. And let us just print the model quickly to see what we have done. Okay, so this is just, we can also split it in multiple cells, and probably that should have been a better idea. But let's first go to the objective, and you can see here it's to minimize, and you can see 21 x 12, and if you check your data, uh, you'll see that 21 should be multiplied by x12, then 35 should be multiplied by x13, 22 should be multiplied by x14, 37 multiplied by x15, 28. So it's kind of like random checks to make sure that what you have entered is correct. And the logical errors are always challenging, and usually the debugging through printing is one of the way to catch the logical errors. All right, so we are done with model objective. Okay, and
Doctor,
yes,
can you just go back to how do you create the dictionary, the second part of the dictionary?
what I did, I have looked over all the values of i's, and then I said whenever I is greater than j, which is the lower half, then copy it from the upper half. So dij is dji, and I'm doing this because the given let me bring it here. Uh, the given data is symmetric, so that's why I'm saying that the upper half is same as lower half. But if it's not the same, then I have to go through the same task of oh, it's not same actually. There's a small difference, right? 45, 35. So anyways, just to save time, I just copied the upper half and lower half, but there is a difference actually. Now I see that there is a difference. So in your case, in the homework, either you enter everything like this, or you copy this in your Excel file and then read directly from the Excel, whatever is easy. Okay, but you have to have a dictionary where the keys corresponds to the index of the variable.
Okay, thank you.
Can a NumPy array be used instead of a dictionary here, Doctor?
You can also use NumPy array, but NumPy array or using any arrays, you have to be very careful because the arrays and the list always starts with 0
Hmm.
and ends at a number. So you have to be very careful. If I, let's say, for example, using NumPy array, I have to be careful to do this um, adjustment of the
Yeah.
index. And that's why dictionaries are preferred, because you might have any, because I started with something very basic, I skipped this, but you might have sets that might contain not only numbers, you might have sets that contains, let's say, alphabets. So if that's the case, then dictionaries are the only way to go, because then how would you
Yeah.
create a minus one? So yeah, you can use any data collector, you can say, but dictionaries are preferred. All right, so here we created the objective. Now let us do the constraint. I'm dividing into two cells just to show, well, let's continue in one cell first. Nothing big, okay. And then let's say model dot c1 dot add. And what do we have? We have summation over xij summation over xij equals to 1 for all j. You see here, this is the constraint. We are summing over I and repeating for all j. So this is like enumeration over j. So let us write it for 1j and then we repeat it. Okay, let us write it for 1j and repeat it. So what is the thing? Summation over I, xij. So I'm going to say model dot xij for I in model dot I if I not equal to j. So inside the sum, you see here I'm saying index I in model I. What I'm saying is summation over I xi. So the first index, I'm summing over the first index. Look here, first index is I, and this for I in I is in the summation. So this is exactly same as saying summation over I xij. Okay, everybody get this? Summation over I xij, the first index in the summation is the first index, and here is the summation over I. You see here, this is the first index, and in the summation, that's the iterator. Okay, and I naught equals to j is just mimicking this part, I naught equals to j. So this is for one j, for one j. Now I have to repeat it how many times? For all the j's, right? So now I need some loop. So I'm going to say here for j in model I, and remember, when you create the sets, you can iterate over them. Sets are basically, built for, iteration purposes. So I'm going to loop over all j's that are in I, and then I'm going to add the constraint one by one. That's so easy. Okay, so now that's constraint one. Anybody has any doubts or questions on this? Look at this model and try to put them side by side. Look at this model uh, and look at this. Any doubts, any questions on this?
If you can repeat it for one time, it will be great.
So the actual constraint is like this. This is strange. Sometimes it doesn't write. Let me just restart this or what? The app. I mean, restart the app. All right, so it's working now. So the constraint is like this. Oh, okay. Something not right. Yeah. So there you go. So the constraint is like this: summation over I. What are we summing? We are summing something. Let's say xij. Okay. And this is for all. Let's use blue color for all j. So see here, if I'm summing over I, the first index is I. So this is the summation over I. Okay, summation over I. And then this is for all j, and that for all j is captured here. For all j. So that is how you can see. Okay. And ideally what we
Yes,
want
clear.
is okay. And now I want this to be equal to 1. So I'm going to add that part here. But is this clear how the summation index goes and how the enumeration index goes, where they go, any?
Yes.
All right. So let's go back here, and then I'm going to say this everything is equal to 1. So there you go. I have the first constraint. And now it's very easy. I'm just going to copy paste, and I'm going to say here C2. Okay, and you see here, there is not much difference. The only difference is instead of summing over I, I'm summing over J and enumerating over I. So just replace I with J. I could do exactly like in the slides, and then this is what it will become. Or I could have just changed here ij. So now we have the second constraint. And finally, the last constraint. The last constraint is a constraint that is for every I and j. So it's kind of like a double loop. You can use different ways of creating nested loop. I'm going to go with the very basic way, which is just repeating the loop, but you can use iter tools. You have interesting iter tools available. You can use them if you want. Okay. So C3 dot add, and what do we have here? Yeah, model dot u I plus 1, okay, is less than or equal to model dot u j plus n, the n that we have defined here, okay, n times 1 minus xij. Okay, so this is for all I, for all j, okay, for all I, for all j, ui plus 1, oh, ui plus 1 less than or equal to uj plus n 1 minus xij. Okay, ui plus 1 less than or equal to uj plus n times 1 minus xij. Everything looks good, but here we have certain restrictions. And these are very easy. Now you can see for using the for loops, these are very easy. So what basically you have to do is you will not add the constraint if I is equal to j. So I will say that I should not be equal to j to add this constraint. Okay, so that's one restriction. But is it the only restriction? No, the other restriction is that I and j should be beyond 2 or more, not 1. So I can say here if this is true and I is greater than or equal to 2 and j is greater than or equal to 2. All right, and we have the constraint here. Okay. Now let's verify this constraint. To verify a single constraint, I don't have to print the entire model. I can, for example, do model.c3 dot preprint. And this will save us a lot of time, and you can see each and every constraint written for you. You can do further things, and you can loop over model.c3. You see, remember, you can loop over model.I, you can loop over model.x. They are all dictionaries. That's how they are handled. So model.c3, you can loop over. It's an iterator, not dictionary. Sorry, it's an iterator. You can iterate over it. So model.e3, you can iterate, and you can print only few if you want. If you want to, let's say if you have thousands of constraints, you know, you'll never print all of them. You just print few of them and check. But here I'm just printing all of them to show you that this is how it prints. A specific element you can print, and you can see that u2 plus 1 minus the way it writes the constraint is not the way it's written here. So what it does is it brings everything on one side, and it says that the lower bound and upper bound. Okay, so you can write a couple of constraints by hand and check whether they are correct or not. I believe that they are right. We have used the same style without any additional modifications. Only thing you need to check is that is 2 or 2 being repeated? No, I don't have 1 here or 1 there. That's correct. So it means the constraint restrictions are working fine. So it's a quick check, and that's it. Okay. So now that the model is built, let's use another cell to solve it. And to solve it, I will just copy paste the code from here, which is this part. Okay. And just to now, because you have integer model, let's to see what exactly is the output. Let's say the t is true, and let's see the GLPK. So that is the kind of output you get in GLPK for branch and bound. Okay, it does a couple of things. First, it solves the LP relaxation, optimal LP solution found, and then it says integer optimization begins. So the root relaxation have solved, and then it's doing the branch and bound tree. I think it's showing after every 10 node or something the update in the branch and bound. Here it calculates the duality gap. It calculates here, I think, the best solution, and it says now the tree is empty and all the nodes are pruned, and finally it concludes that it found an optimal solution. Of course, each and everything you can catch and print if you want. If you're only interested to know whether you have an optimal solution or not, you can also check only that part. But this is the entire uh, summary of what the model did for solving the model. Okay, and once you have the results, if you want to print the solution, let's do it in another cell. I could do, for example, model.x.p print. Okay, and it gives me the values of x. It gives me everything. And if I want to avoid that, I could say model dot for I in model dot I, and I could say print model dot x of I dot value. Because remember before we had a single variable, so I'm just going to say model x dot value. Here we have not a single variable, indexed variable, so I have to do xi dot value. In fact, this will print everything like before. I don't want to print everything like before. So what I'm going to say is I'm going to say if model value is not equal to none, then you print it. Okay. Something is not right. Oh, my bad. Xij is it's a double index variable, right? So it should be ij. Okay, so xi comma j. Okay, I comma j. So it prints all the values. Again, you see you have zeros. Maybe you don't want to print zeros. Okay, then you can add another if statement saying that if the value is strictly greater than zero, then you print, and it prints only one, but still it's meaningless because what is I, what is j, I don't know. So now is the time to print everything ij model, and it says okay, from 1 to 4 you go, and then from 4 to 5, then 5 to 6, 6 to 3, 3 to 2, 2 to 1. So that's a tour, complete tour. And then you can beautify, you can pretty, make the code pretty, and you getting the results. You can also print the values of variable u and so on and so forth. So essentially, this is how you can solve a mathematical model, which is almost a typical mathematical model that you'll find where you have restrictions uh, in the enumeration and restrictions in the summation, and you have notation and indexed space variables and parameters. Okay, so that's a quick short can say workshop where we have seen how to model MIPs using Python Pyomo and the GLPK solver. Okay, so yeah, it's almost 2 hours. Usually, one session is not enough, especially when we start from scratch and builds something to this level. But I hope that with this and with the practice that you get do through the homeworks and through the project, you guys will be good in using this software. Okay. So I think this is the right time to stop. Any questions, any comments, please let me know, or we can stop here. And the meeting is recorded, so you guys can come back to it later as well. Yes, Saleh, you have something?
Uh, can you share just the coding files or just pictures of them?
I will share this model 3 and model 1, and I suggest you guys, if you are interested, work on model 2, which is actually what I should have done, but for the time I just skipped it. Work on model 2 and also see if it gives you the solution or not. And if you find any difficulties, let me know. Okay, so I'll share the two models in the chat now. Anything else?
If you can you share just also the second practice to have reference if we have mistakes so we can check what are they for, I mean, for model 2 because we solved 1 and 3.
Have it ready. Maybe I have it from the check, but since model are in front of,
Sorry, doctor, your sound is not clear.
yeah, I'm saying that model 2, I may not have it ready with me, so I need to check if I have. Otherwise, I will write it and send it to you guys. But 1 and 3, I'm sharing it now in the chat. Okay.
Thank you.
All right. So that's it. So that is how you can use an open source. By the way, most of you guys maybe started your programming experience or programming journey through Python. So what we did in today's session in 2 hours might look trivial, but believe me, when we were students and when we wanted to do the same thing with C++ and Cplex, for this TSP model, it took more than 2 hours just for the TSP model, and in fact, it took quite long time to debug and make sure everything was working perfectly. So Python really made things much simple, and you might think that things were simple since the past, but it's not the case. So just that you guys got lucky to start programming in Python. Most of you, I know, and undergraduate students at KFUPM got this. So things becomes easy or smooth. But trust me, if you go back to using Java or C++ and build this TSP type models, you will be facing, you will not be doing it in 30 minutes or 40 minutes that we spend on Model 3. Okay. So Python, Poemo again, it's just your choice. You can look for. I'll show you some more. I'll show you maybe one more interesting library. Poemo I have shown you. Pulp is another interesting library. You know, that you can, if you want, look at it. So this is dedicated to only linear and linear integer programs, which is what we have done in today's class. Poemo is more generic. You can also have nonlinear, and Poemo can model it. So you have many such libraries out there. Pulp, if you are sure that it should be linear, then go with Pulp, or going with Poemo. Uh, Poemo is also a good option. Poemo has a good documentation. One of the, I think, extensive documentation that I found is in Poemo. If you go to the Poemo documentation and examples, you'll find that lots of documentation and examples are here, and it's a good resource to go over it. The Poemo book is again open for free, especially from the Springer. As a KFP student, you can get it, and it's an interesting experience, and it will be a good choice. And if you're not sure of anything, just go with Poemo, at least for the beginners. And later on, if you go to a specific area for your research, you can pick a solver, and maybe you can code directly for the solver. That is also a good thing, but this is general purpose and probably something useful for you guys. Okay. So with that, let us stop. Dr. Ahmed, do you like to say anything, or do you have anything to say? Hmm. Okay, I think then that's it. So let us stop here. Okay, guys, have a good, not good night, and you have a good sahur. I think it's almost the time for you and for me to have sahur, maybe, or maybe in a couple of hours. Okay, so that's it. I'll stop sharing the screen now. Okay. So,
Thank you, Dr.
okay. Thank you all for attending.
Uh,
And Dr. Ahmed.
Thank you.
Doctor,
Yes, Saleh.
may I have a small question, please? You said that we